Hi, and welcome back to the Implementing and Administering Cisco Solutions, the CCNA 200-301 video series course by EC Console. My name is Glenn Singh. In this video, we'll take a look at identifying interface and cable issues on a network. So let's dive on in. A physical issue can cause many types of problems, and these problems can start as a small problem and grow and affect all users on a network. A physical issue can be caused by, let's say, packet loss and even by high latency on the network. Packet loss simply means that the packets that are being transmitted between a source and a destination is being corrupted or being lost on a network. In most instances, they are mostly corrupted on a network. And being corrupted, a receiver device or a device on the receiving end will simply discard any corrupted messages. Physical issues can also cause high latency. Latency is simply the measurement of a response between a source and destination. High latency simply means that a device will take very long to respond. So the objective of a network engineer is to ensure the network has very low latency. On an interface, there's two types of configurations that can simply, let's say, result to either creating packet loss and latency issues. These are duplex and speed. So later on, we'll take a look at actually configuring duplex and configuring speed on a Cisco switch. But for now, we can determine that physical issues can be caused by one of two things. It can simply be that there's a faulty network interface card on a device. If there's a faulty network interface card on a device, simply shut down that interface, reprovision a new one, and switch the cable. As in, remove the cable from the faulty interface and plug it onto the new interface. Additionally, you can have a faulty network cable. A faulty network cable, such that let's say you determine the cable is bad, simply change the cable itself. One of the very first things that you can do as a network engineer is to actually isolate what the physical issue is. So the first thing you can do is simply change the cable with a new cable. If the problem persists, it means to say most likely it's an interface that may be faulty. Simply shut down the interface, reprovision a new one, and connect the cable to the new interface. There are many types of interfaces on a Cisco switch, and even a router, and even devices such as end devices and even access points. A typical Cisco switch, or a router, or even a firewall operates in these three different speed modes. A Cisco switch, router, firewall, or an access point can operate in either of these modes. An Ethernet interface simply operates at 100 megabits per second, while a fast Ethernet interface operates at 100 megabits per second. A gigabit Ethernet interface operates at 1000 megabits per second, and the interface can be configured to operate as auto. Auto simply means that if it is you connect any device to, let's say, another. So imagine we have a switch, let's call this switch 1. Switch 1 is connected to, let's say, PC 1. Now, if PC 1 has a fast Ethernet interface, it means to say the fast Ethernet interface can operate at either 10 or 100 megabits per second. If the switch interface here is a gigabit Ethernet interface, the switch interface can simply operate at 10, 100, or even 1000. So both of these devices, if their interfaces are configured to be auto, both of these devices' interfaces will simply negotiate for the highest possible speed that they can operate on. And the highest possible speed between two of these interfaces is 100. So therefore, this link will operate at 100 megabits per second. That's the benefit of using the auto feature. Another feature under a Cisco interface is known as the duplex. The duplex is simply the method or the common method by which two devices can exchange data. Similar to speed, there are three modes. There's half, full, and auto. Please keep in mind that auto is the default for both speed and duplex. With half duplex, only one device can communicate at a time, such as on a hub network. With full duplex, two devices can simultaneously communicate. So this means if we have two switches, let's say switch 1 and switch 2, if both of these interfaces are configured as auto, they will most likely negotiate and create a full duplex between these two interfaces. However, if one side is set to half duplex while the other side is set to full duplex, you can experience some packet loss and some latency issues, because it simply means that they are not negotiating their messages or exchanging messages properly. It is simply key to ensure that both of these interfaces are configured to match the other side. So this means if switch 2 is operating or is configured to be full duplex, then switch 1 should be configured to be full duplex as well. This would mean that both of these devices can exchange information simultaneously. You can simply use the show interfaces command on your Cisco switch or even your Cisco router to simply verify and even check physical issues. On each interface, there are interface counters which are used to indicate if there are any sort of physical issues that exist. So before we take a look at the output of this command, let's take a look at the various types of counters that exist under an interface. Under an interface, whether it's a Cisco router or a Cisco switch, there's what we call the input errors. This counter for the input errors simply provides the total number of packets, or actually the total number of faulty packets that has entered the interface of the Cisco device. The value is the sum of runs, giants, no buffers, CRC, frame, overrun, and ignored counts on the interface. You'll also find runs. Runs are simply packets which are discarded because they are less than 64 bytes in size and are smaller than the minimum packet size. So we need to look out for these runs on the network as well. There are also giants. Giants are simply packets which are discarded because they exceed the maximum size. They are usually greater than 1518 bytes in size. There's also a CRC counter. The cyclic redundancy check, or CRC errors, occur when the checksum within the frame trailer does not match the checksum received from the sender. The CRC value is stored within the FCS, the file check sequence, which is simply located within the trailer of a frame. There's also output errors. These are the sum of the total errors that have prevented the transmission of a message from leaving the interface. You'll also find collisions and late collisions. The collisions, these are simply the number of messages that has been retransmitted due to a collision on the network. The late collisions are simply collisions that occur after 512 bits or 64 bytes of a frame has been transmitted. So now let's take a look at the show interface command on a Cisco switch. So here we have the interface of a Cisco switch. Let us type enable. And let us now do the show interfaces status command first. So looking closely, we can see that fast Ethernet 01 is in a connected state, and it is assigned to VLAN 1. However, the duplex mode is set to auto, the speed is set to auto, and looking at the type here, we can see that it can operate either 10 megabits per second or even 100 megabits per second. Now, let us actually take a look at the show interfaces command only for fast Ethernet 0/1. Alright, so now we have user show interfaces fast CCNA 0/1. We can see the physical status is up, the line protocol is up, the status is connected. We also get a MAC address of the actual interface itself. We also see the duplex. Even though previously we saw the duplex and speed was operating at auto and auto, you can see the duplex is set to full duplex right now as in a current operational state, and you can see the speed is currently operating at 100 megabits per second. The part that we want to pay a bit more closer attention to is this section here. As you can see, we have interface counters. As you can see, we have the total number of packets that has entered the interface, the total byte size, if there are any no buffers. We even see runs. We have no runs. We have no giants. We could even see the input errors, CRC errors, overruns, any sort of, let's say, output errors, collisions, interface resets, any late collisions. So if we see any of these numbers that are incrementing, that are counters, that means there's a physical problem. I highly recommend change the network cable first, and then recheck to see if the numbers are incrementing. If after you change the network cable and you're still getting these counters incrementing, it simply means that the interface itself is faulty. And since that these interfaces are integrated into the switch or the router or let's say the firewall, you cannot change the interface, as in physically replace it. What you can do is shut down the interface, reprovision a new interface that is available, remove the cable attached from this interface and connect it to the newly provisioned interface. So remember, the main commands we take a look at here is the show interface status and the show interfaces command. Now, additionally, what if you want to adjust the speed and duplex on this interface? Well, we can simply go into interface mode like so. Now we can use the speed command with a question mark. So let's say we want to configure the interface to operate at 100 megabits per second. We can simply use the command speed 100 and hit enter. Oops, and I made a mistake, so let me fix it. Alright, what I can do next is simply adjust the duplex. We can use the duplex command. So now let us set the duplex to be full simply by using the command duplex full and hit enter. So notice here that the interface has changed to a down state. Well, to put simply, the interface is resetting. So let's type shutdown and then type no shutdown to bring back the interface. Next, let us type show interface status. And notice now that even though that there's auto previously, it is now set to full and the speed is now set to 100. In this video, we took a look at using Cisco commands to verify a physical issue that may exist on a network. Secondly, we discussed the various counters on an interface to verify whether a physical issue exists or not. In the next video, we'll take a look at comparing TCP and UDP. I hope this video has been informative for you. I hope to see you in the next one.